Good afternoon, everyone, and good to see you back. Today we have a special, it's raining in Gambia, huh? All right. What is this, the raining season? All right, so we have a special presentation today from a Moretti scholar, Samar, who is our statistician for our research projects, and she keeps us honest. So she's gonna give 2 sessions on statistics, and the first session is today, and the second session, which will be on sample size, will be one day in the first week of August. So I think Samar, you know everyone, right? You are.
Yes.
Okay. All right. Good. So very good. So I'll let you start your presentation, Samar. You may want to put it in screen mode.
I already put it in screen. Oh, okay, that's fine.
Right. So
Yeah. Okay. All right. Very good. Excellent. You're on.
Okay. So hello everybody. I think that all of you now know me. I'm Samar Abdel Hafiz, working as an associate professor of epidemiology at Alexandria University. Today we will speak about some steps on the biostatistics and how could we apply it. Before we start, I would like to ask you, if something is not clear, just ask me at any time. Okay? Is my voice clear for you, or there's some issues?
no, it's fine.
Okay. So our presentation today will be about the biostatistics from theory to practice. And this is our agenda. So before we start, let's ask ourselves why it's important to do statistical analysis. Would someone tell me?
To get the meaning from the data.
Sorry?
To get the meaning from the data, the correlations and the description of the data.
And what's the importance of doing this?
It's the core of clinical research.
Okay.
I have data and I need to analyze it so that I can get results.
So let's think about it in a reverse way. The statistics.
Can I say something?
Yes, of course.
Yeah, this is Susan with you.
Okay.
I think statistical analysis starts from the beginning when you do the experimental design.
Okay.
And doing the experiment, and after that you have the results so you can analyze it. So I think it should start from the beginning, from the experimental design. That's my thing.
Yeah, that's right. We should do our plan from the beginning of thinking about the idea. But this is not my question. What's the importance of the statistical analysis? Is it just a way to show off or to present our skills in playing with the numbers? No.
I add something. I think it's an objective way in concluding results from given data.
Yes.
In other words, it's objective. It's not subjective. For example, I see a number between 2 groups, and I see this. There is a difference between the 2 groups. Subjectively, I say this is it's significant. It's statistically significant. But when I do this, the test, it's different.
Okay, let's think in a pragmatic way. Okay, when you speak about these issues, you speak about the techniques of the statistics, but this is not my concern. My concern is most of us are working in the field of the clinical medicine or the clinical research, and the clinical medicine is now important to give an idea about prevention, diagnosis, prognosis, or therapeutic aspects. And to reach to this conclusion, we need to put our decision based on a valid data or valid findings. And to have these valid findings, we depend on what's called the evidence-based medicine. And the core of the evidence-based medicine is the evidence retrieved from doing the statistical analysis. So it's a way, it's a tool. The statistics is a tool to prove our ideas related to how to prevent a disease, how to diagnose a disease or a health-related problem, how to do a prognosis, which is better, which treatment is better. And now we are living in the era of the corona, and we could see this by our eyes, the importance of doing a good research, and good research depends on analyzing the data in the proper way. So this is the step to answer our clinical research question. Is it clear to now?
Yeah.
Okay. So we have two terms that we usually use in the research, something which is called the population and something which is called the sample. So let's speak about this. If we put a research question, and our research question is, for example, we want to assess the prevalence of hypertension among people living in the Middle East. Who is the population and who is the sample? All of us know that it's impossible to do our research on the whole population. This is impossible to do it. This is time wasting. This is financially wasting, this is like we are spending, or we are wasting our resources in something that we can do it on a subsample. So the population, or sometimes we call them the target population, is the whole population. We collect the data from the individuals about an event or criteria from the whole population, okay? Now, as we say that it's impossible to do our study on the whole population, we have to take a sample from this population to do our study on it, okay? So we have now the sample, and the sample is a subset of the population. Now we do our analysis on the sample, or our research on the sample, but we are seeking to generalize our findings on the population, okay? So this gives us an idea about the importance of proper selection of the sample from the population. When we select our sample in a proper way from the population, this means that our sample will be good representative of the population. Is it clear to now? Hey?
Yes, yes.
Yeah.
Okay. So we use two terms in the research, the population and sample. And sometimes you call it the target population, and the other group is the study population. Our research is done on the study population, but our results are aiming to be generalized on the target population. Okay?
Okay.
We say that we have target population and study population. Now in the statistics, to be reflected on the statistical measurement, we have two terms also, something which is called the parameter, and the other term is called the statistic. The parameter is the test when we do it on the population, on the whole population, on the target population. And it's usually unknown. It's in the theory, but this is usually unknown. This is what we want to reach to it. To reach to the parameter, we do our research on the sample, and what we calculated from the sample is called the statistic. Okay? So please, all of us unmute yourself,
Yeah.
because we can interaction. Otherwise, I will not be able to understand whether you understand me or not.
Yeah, we are following.
Okay. So we have the parameter, which is calculated from the target population, and the statistic, which is calculated from the study population or the sample. When the study population or the sample is properly selected from the total population, the statistic will be very close to the parameter, okay? So when is the statistics is simulating the parameter, when I select my sample in a proper way from the target population. Is it clear?
Okay. Yeah, it's clear.
But, Samar, go back.
Yes.
To the, what a measurable characteristic of a population. Give me an example of that.
Like the serum creatinine level of all diabetic patients.
I'm sorry?
Like the serum creatinine level of all diabetic patients.
The serum what?
Creatinine.
Oh, creatinine?
Yeah.
Well,
So when, for example, let's say an example. If I want to assess the renal impairment among all diabetic patients living in Egypt, okay? Now I have to take all diabetic patients in Egypt and do for them the renal function test, okay?
well, so wait, so a measurable characteristic of a sample, well, I mean, that could be creatinine too.
Sorry?
That could be serum creatinine as well.
Yes, exactly. It will be the same. But when we collect the data from the total population and calculate the mean of the level of the serum creat from the total population, from the whole population, it's called the parameter. But when we calculate it from the study population, it's called the statistic.
Okay.
Dr. Samar, can I ask a question?
Okay, just a second. I will let you ask a question. So now we want our research question is to know the mean of the serum creat level among all diabetic patients. This is our research question. Is it clear? Okay. So the mean of the serum creat among the whole diabetic patients is called the parameter. But as we are not able to calculate the parameter because we cannot do our research on the whole diabetic patients, we take a sample from the diabetic patients. And this sample, when we calculate the mean of the serum creat among this sample, now it's called the statistic.
Yeah, okay.
Okay. So be it.
Sorry?
So be it.
Okay, good. Who wants to ask?
I just want to ask, then when shall we calculate the parameter? If it is
We
impossible.
never calculate the parameter.
Okay, so this is the answer. Okay.
Yeah,
Oh,
we never calculate the parameter.
We'll never use the word parameter again.
Yeah,
It's
This is
like it's like the measurements we seek to reach.
Okay,
And
all right.
but it's never
Yeah, this
applicable.
is, yeah, it's just in the theory.
Yeah.
So as long as we take our samples in a proper way, I think most of you heard about the random sampling and how to select the sample from the population. So when we pick our study population in the proper way from the total population, what we will calculate from the sample, which is the statistic, should be very close to the parameter which we look to reach to it.
Okay. All right, good. Great.
Okay? Okay,
Excellent.
Dr. Okay. Now we have other two terms, something which is called the data and something which is called the information. What's the difference between both terms? The data are simply the raw data that we collect from the study population based on a questionnaire, based on lab investigations, based on clinical examination, whatever we collect. And these data are collected in a raw way or an haphazard way. When we start working on this data, when we start to process this data to answer our research question, now we could retrieve information from this data. We could conclude that diabetes is more common among males than females, cardiovascular disease is more common among males than females, and all these conclusions are based on processing our data. So the information we got from processing the data is what we could be able to answer our research question. So when we process the data, we aim to reach conclusion through giving some information. Okay?
Yeah.
Okay. Now, And all of this is, all what we speak about is just the introduction. Now we will start speak up in a statistical language. The basic unit of any statistical analysis or any statistical technique or any statistician, something which is called the variable. So what are the variables? And how, when we could say that this is variable? Let's look at this. Now we have, this is like a matrix and we have columns and rows, okay? And this way of presenting our data is the same way in all statistical programs starting from Excel up to SAS. So this is which way you have this matrix, rows and columns. We put, could you see the cursor when I use it to move on the screen, or you don't see the cursor?
No, we don't see.
So let's use this.
Yeah, now sometimes it appears. Now yes.
Now it's yes.
You could use the annotate tool.
Yeah, I was just saying this, but okay.
There you
So now we have, oh my God, what is it? No, it's not working. Let's see. So now we have the rows and we have the columns. The rows represent the individuals or the patients or the study unit. So for each row, we have we have data for each person included in our study sample. Let's look at this. So this is patient number 1. We have his gender, we have his age, we have his weight, and we have his height, okay? So this is the data for each patient. Is it clear?
Yes.
Yes.
But this is not the thing we use in the statistics. We use the data collectively. So we want to know the gender distribution of all patients. Now we look at columns, not rows. The age of all patients, the weight of all patients. So when we are concerned with the data from all the study population, now we can say that this is our variable. So the gender is variable because it represents the data for all study population. The age is a variable because it represents the data for all the study population, and etc. So when we look at the variables, we look at the columns. And when we look at the data for each patient, we look at the rows.
Yeah.
Okay?
Yes.
Okay. Okay. So we speak about variables, but is it easy in this way to say that it's variable or it's not a variable, and how can we use it in the statistics? Before we start using the variables, now all our statistical analysis will depend on variables, okay? So before we start doing our statistical analysis, we need to understand the different types of the variables. Does any one of you know the different types of the variables?
Yeah, like, okay, sir, go ahead.
Who is speaking?
Numerical and categorical.
Okay.
There is like a dependent variable and independent variables.
Okay, it's another way to classify, but okay, we will speak about it later.
It's categorical and continuous.
Okay, so Dr. Sarah said numerical and categorical. Dr. Said says categorical and numerical. Do you have any addition?
You have ordinal, nominal variables.
Ordinal and nominal, yes. So,
Quantitative and qualitative?
Yeah, exactly. Okay. So we have two large families, qualitative and quantitative. And under these two large families, we have all these subtypes you mentioned, numerical, categorical, ordinal, and continuous. So let's take one by one. what's the qualitative and what's the quantitative variables? And when we say that this variable is a quantitative variable and this variable is a qualitative variable, to put it as a rule, when we measure something or calculate something, this variable will be quantitative because we have it in a form of numbers, like the age, like the level of the blood pressure, like the level of the serum cholesterol. So this is quantitative because we collect our data in a way of measurement or counting. Okay? The other type is qualitative. What are the qualitative variables? If we describe something, if we say that we have 50% of our sample is male and 50% are females. So we describe by yes or no, by grouping, that we have 10 population with grouping with blood group A, 10 population with blood group B, 10 population with blood group AB. Okay, so when we have the data in numbers, usually the variable is quantitative, and when we have the data in description, usually the variable is qualitative. Under these two big families, we have subgroups. For the qualitative, we have two types of the variables under the qualitative: the nominal and the ordinal. What's the difference between both of them? So now we understand that the qualitative variables are the types of the variables that answer our question by in descriptive way. So if we ask about grading of the disease or the degree of pain or the level of social class, could we put it in order? Yes or no?
Yes.
Yes. So when we are able to put our variable in order, mild, moderate, severe, low, middle, high, grade 1, grade 2, grade 3, now we call it an ordinal qualitative variable. Okay? When we are not able to put our data or our variable in an ordinal way, but it's still describing a situation, it's called nominal, because we cannot say that the females are better than males. We cannot put it in order. So now it's a nominal qualitative variable. The sex is a nominal qualitative variable. The same for blood grouping. Could we say that those with blood group O is better than blood group A? We cannot say this. So this type of the variable is nominal qualitative variable. Is it clear?
Yes.
May I ask, for example, if the degree of pain we are putting a scale from 1 to 10, then this is going to be quantitative?
Okay. So for the scales like the Likert scale, by default, this type of the variable is a qualitative variable, because this is the numbers itself don't represent the measurement. The numbers reflect like strongly agree, neutral, or don't agree. Okay?
Yeah.
This type of the variable is a qualitative variable.
Mm-hmm.
The correct answer. In real life, you will never see anyone who is dealing with the scales based on qualitative way. They will analyze the data from the scales as if it is a quantitative data.
Yeah.
Answer your question?
Yes. Yes.
Okay.
So,
but even if the degree, like the pain score from 0 to 10, 1, 2, 3, 4, it's the same, like the Likert scale?
Yes, it's the same. It's the same. And sometimes to overcome this issue, we usually, when we will speak about how to summarize our data, we will understand this concern. So to overcome this issue, we represent it in the two ways. So we put the mean and standard deviation for the scale, it's for the scores of the scale, and we put like a cutoff point for the scale to say that those are like moderate and mild and severe, to represent it in a qualitative way to overcome this issue.
Yeah.
Okay. So
wait a second. You're saying from a Likert scale, it's quantitative?
no, it's a qualitative. By default,
okay.
it's a
All
qualitative.
right. That's fine. That's fine. I thought you said quantitative.
No,
Right.
qualitative. But I was speaking to Dr. Sarah that although it's a qualitative, but in all publications they deal with the scale as if it's a quantitative, and they present the scores in the form of quantitative data. So we put mean the standard deviation for the score, although the score itself don't represent the grading of the scale, but the scale is a qualitative. Okay.
Okay, good.
Okay, and this is for the qualitative variables. Is it clear for you what's the qualitative variable and when we call a variable a qualitative one?
Yes.
Okay, now we go to the quantitative variables, and as we say that
there is also the binary data, right? The yes or no.
I'm sorry?
Binary.
Binary.
Yes, it's a subtype. It's a subtype of the nominal. It's a binary or categorical.
Okay.
The sex is a binary variable. Blood grouping is a categorical variable. The binary variable is the variable which has two answers, like yes or no, or two male and female. The categorical is the variable which has more than two answers.
More than two.
Like the blood grouping, like the chronic disease. So it's a subtype of it.
Yeah, okay.
Let's don't complicate the issues too much, okay?
Okay.
For the quantitative variable, as we said that the quantitative variables are the variables that could be measured in a numerical way. We have two types of the quantitative variables, something which is called the continuous and the other type is called the discrete. What's the difference between both of them? The continuous is the variables which I could present with fractions or with decimals. So like the hemoglobin level, I could say that my hemoglobin level is 13.5 or 11.9. So I could put like a fraction. The value of this variable could have a fraction and it's acceptable. The age, I could say that my age is 11 years and 6 months, so 11.6. So this variable is a continuous variable because it could have fractions. The values of this variable could have fractions. Okay?
Okay.
Yes.
What about the discrete? The discrete is also counts and numbers, but it couldn't have fractions. Like the number of my fingers per hand. How many fingers do I have in my hand?
5. You
Could
cannot say.
5.5?
No, you cannot say this.
Never. So when the variable couldn't be fractioned, it's called the discrete, although it is still presented in a numerical way, but it's couldn't be fractions. When I ask someone how many family members do you live with? Let's for me, my family member is 5. Could it be 5.5? Never. Okay. So this is the type of the variable which is called the discrete quantitative. Okay.
Okay.
Okay. Before we jump to the step, let's go to the exercise just to refresh your. We need to do the part 1 of the exercise. You have the exercise, right?
You want to put them in breakout groups?
Yes, I will put them in just a second.
All right, let me make you the host.
Okay.
Can't we do it all together?
As you prefer. What's about this, Dr. Silverman? But Dr. Silverman wants you to think about it with yourself, just for 5 minutes only.
Yeah, no, yeah. Why don't we do it in groups? Because let's see how it goes.
Okay.
All right. All right. So you're the host. Why don't you just put them in 2 groups?
Okay.
So this way, everybody will have a chance to talk.
Okay. I put them.
You put everyone?
Yes.
Okay, good.
So could you do the part 1 only?
Okay, you could talk to all of them.
Yeah. So now we have we have the first we have like a table, and we have the first question to describe the type of each variable, and the second question and third to describe the type of the number of a children group and the LDL cholesterol group. So you have like 5 minutes to think about it.
Okay. You're using a lot of clothing there, my friend.
Yeah, exactly.
Yeah, you're going to get us into trouble.
No, I take it back. I know where it goes.
Yeah.
I make a regular trip.
A regular trip.
Yeah.
Okay. Yeah, so do I.
I'm trying to get a color that actually matches the one that I have on.
Oh, yeah,
But
don't be.
apparently that ain't happening.
Don't worry. We won't report you for using different shades of blue.
To the scrub police.
Yeah,
See you
right.
later, Henry. What is all this stuff? Is this your stuff?
What's that?
Is this all yours?
Yeah, right.
Wow.
Yeah. So I'm doing virtual teaching with my folks in Egypt.
Ah. You're gonna set up like the Premier Soccer League in here. You got like 10 televisions going.
Yeah, right. Yeah, right. Game day.
Are you done?
Are you talking to them?
Yeah.
I'm not sure if they can answer you. Why don't you just close the rooms?
Okay.
And then they have 60 seconds to come back.
Okay. I closed the rooms.
Are you able to share your document?
Yes, I shared it.
No, on the screen.
Yes, it's already shared. Okay.
Oh, okay.
Did you manage to answer the questions?
Yes.
Okay, so let's start discussing it together. Who is the first volunteer?
So for the
Let's take it one by one.
okay.
Okay.
So
Who
ID
wants to?
is qualitative nominal. I can start.
Sorry?
ID
Okay.
qualitative nominal.
Is it a variable?
No.
Mm.
No, it's not a variable. Just
No.
it's not a variable because
Yeah.
the ID, it does not measure or count or describe.
Yeah, that's right.
Yeah.
Okay.
Mm-hmm.
Yeah.
Okay, so it's tricky.
Yeah, it's tricky.
Yeah.
So for age,
This is a quantitative continuous.
Quantitative continuous.
okay. Gender,
Qualitative nominal.
okay. Height,
Quantitative continuous.
okay. Blood group,
Qualitative nominal.
okay. LDL,
Quantitative continuous.
and feeling happy.
Qualitative ordinal.
No, it's not ordinal. Why it's ordinal? Someone is happy, someone is not happy.
But it's graded.
Strongly agree, indifferent. It was
It's
like
a scale.
Yes, yeah, you are right. It's qualitative ordinal, right? I'm sorry. Yeah. Number of children?
This will be quantitative discrete.
Exactly. Where are the other people? They are not answering. Are you following with us?
I will not answer any.
Yeah.
Yeah.
Yes, Maha is our team leader, so she has written down all our ideas.
No, I need to hear all your voices.
Oh, so what did you have? Elections?
Democratic election.
I see. Okay. All right.
So, smoking?
So smoking can be nominal if there is a smoker or non-smoker, or can be ordinal if I will assess the class or the degree of smoking.
Okay, here you have the answer. They have the variable of yes or no. So in this form, what's the type of this variable?
Yeah, in this form, yes or no, it will be nominal.
Qualitative nominal. And in this case, Dr. Sarah was asking about the binary. Usually the variables with yes or no, we call it binary variable. It's a subtype of the nominal variable. Okay?
So if you ask for how many packs a day of smoking,
Yes.
and convert it into pack years, would that be then quantitative?
Yeah.
Quantitative, exactly.
Okay, all right, good.
Social class. Nice. Social class. What's the type of this variable?
Qualitative ordinal.
Qualitative ordinal.
Qualitative ordinal, exactly. Okay. Let's jump to the second question. So which of the following keywords best describe the type of the variable?
I'm sorry,
We just did the first question.
I'm sorry?
Dr. Samar?
Yes?
I'm sorry, I couldn't understand about the feeling happy category in the exercise number 1.
Yes. So
Yeah.
what's not clear for you? Dr. Sausan, I think?
Yes, I had the disconnecting from the group, so
okay, so
I couldn't catch up everything.
What's not clear for you?
I just wanted to make sure, is it qualitative? It's considered qualitative?
Yes, exactly, qualitative and ordinal, because now we have it as strongly agree, disagree. So we have like grading. So it's a qualitative and ordinal. So the big family is a qualitative and ordinal because the answers here is in a form of grades.
Yeah. Thank you.
Dr. Sausan, do you follow?
Thank you. Yeah,
okay.
Thank you.
So the second one, second question.
Yeah.
Which of the following keywords best describe the type of the variable number of a children group? What do you think?
Shall I answer?
Yes, of course.
Numeric.
I'm sorry. No,
numeric,
I didn't hear you.
Quantitative. Numeric, quantitative.
Huh? Okay.
Quantitative, yes.
Okay.
And
are you
discrete.
sure? Are you sure?
Yeah.
Does anyone have another answer?
It's ordinal. It's qualitative ordinal.
Sarah, it's about number of children group, like the last column, not the one before the last.
Exactly.
Group. Oh, okay.
Yeah,
I thought it's the second column from the right.
Exactly, and this is the trick.
Yeah. Okay.
We have two variables about the number of the children. We have the number of children and number of children grouping. So number of children is like when I ask you how many children. So the question will be, how many children do you have? You don't have children, or you have 1, 2, 3, up to 6. When we have the question in this way, it's a quantitative discrete because it's impossible to have 2.5 children. It's usually we don't have fractions in this. So the number of a children variable is a quantitative discrete. Now the researcher did another modification on this variable, and he grouped the population. He says that I want to group the study population based on the number of children they have. So for example, if someone has 0 to 1 children, I will put all of them in one group. And all other people who have 2 or more children, I will put them in the other group. So now we have 2 groups. The first group is the study population who have either 0 children or 1 children, or 0 children or 1 child, and the other group who have 2 or more children. So in this way, when I grouped this variable, what's the type of this variable?
It's qualitative here.
Qualitative, exactly.
Categorical binary. I'm not sure about binary.
Oh my God, how could it be categorical and binary? Binary is groups. Categorical is more than 2 groups.
Categorically, yes.
Okay. Yeah. Okay. So it's
okay.
So I mean nominal, right? Nominal, not categorical.
Nominal. It's nominal. Yes. It's ordinal.
So,
it's ordinal, not nominal.
Ordinal? Why?
Because 0, 1, it's they have 1 children is less than 2 more. So you could put them in order.
Yeah.
Ordinal? Okay.
0,
okay.
1, and 2 or more.
Okay. So it's not binary.
Yeah.
Okay. Good.
So for the LDL grouping, the variable which is called the LDL group, do you see this variable here?
Yeah.
The fifth column. Could you see it?
Yeah.
What's the type of this variable? Let's start from the beginning. Is it qualitative or quantitative?
Qualitative.
Exactly. Qualitative. It's ordinal or nominal?
Ordinal.
Ordinal, exactly. How many groups we have here? 2 or more?
High, near optimal, high, very high. We have 4.
4. So it's a categorical. So now it's a qualitative, and then it's ordinal, and it's categorical. Okay?
Yeah.
Okay. So let's back to our presentation.
So Dr. Samar, either nominal or ordinal, if there are more than 2 groups, both are category, right?
Yes. So the categorical or binary depends on the number of the groups. The nominal and the ordinal depends on whether I can put it in order or not.
Yeah, right.
Okay. Now as we understand now the different types of the variables, we need to understand how could we summarize our data from these variables? How could we present our data? So always remember the classification of the variables, because this is the starting point from which we will speak about the analysis till the end of the presentation. Okay?
Okay.
So we have 2 types of the statistics, something which is called the descriptive statistics, and I think all of you hear about this when you are doing your thesis, and something which is called inferential statistics. We will start with the descriptive statistics. What's the descriptive statistics? Simply, it's the way to summarize or describe the data from our sample or our population. And it depends on the type of the data, type of the variable, and its distribution. Okay? And we have two types of the organization of the data. Something which is called measures of central tendency, and something which is called measures of the variation. And we will speak about each one of it separately. Okay?
Okay.
So before we start to describe our data, we need to know that we present our data either in graphical presentation or a tabular presentation. So when we do our research, we say that we will present the data in tables, or sometimes we add the graphs to make it simple because the visual impact of the graphs is better in reading the data rather than the tables. Okay? So how can we do this, and how can we do that? Now, we will always start with the qualitative variables because it's easier to present it rather than the quantitative variables. As we say that, what are the qualitative variables? What are the qualitative variables? They are the variables which describe, and we could have either either we could have the qualitative variables either in a nominal or an ordinal way. Okay, so let's have this example. Now we have 100 patients with pneumonia. For people who are not from a medical background, pneumonia is like chest or respiratory disease. And our research question, we want to know how many patients are in each pneumonia severity index class. So now what's our variable is pneumonia severity index class, and this class classify patients into like mild pneumonia, moderate pneumonia, severe pneumonia. What's the type of this variable?
Qualitative
ordinal.
Qualitative ordinal, exactly. How can we present this data? We present the nominal or ordinal data, or all the family of the qualitative data with what's called bar chart. Okay? What are the criteria of the bar chart to make it very clear? So the bar chart is used for categorical variables, okay? And it can use the counts or the percentage on the y-axis. So for all the charts, we have x-axis, the horizontal axis, and the vertical axis, which is the y-axis. What we should put on the y-axis? In the bar chart, we should either the counts or the percentage, while it's usually preferable to put the percentage. Why it's usually preferable to put the percentage? Could someone answer? And this is very important in marketing.
In what?
In marketing.
It better shows the relationship between the variables?
Yeah, more or less, yes. For example, if we use the counts, it will be deceiving. For example, if we say that this drug was effective in treating 1 million thousandths of the population, okay? When I put on y-axis the 1 million thousandths of the population, the bar itself will be very tall.
Yeah.
The of the bar will be very high, and then it will give a false impression, wow, this drug is very effective. While this 100,000 population could be a very tiny percentage from the total population. So it could be like 0.1% of the total population. So usually in marketing, they depend on this to give false impression about the usage of their products, the effect of their techniques, whatever. While in reality, and from a scientific point of view, we usually prefer to present the data with the percentage, not the counts. Okay? What's the second important criteria of the bar chart is there is always a space between bars. Bars are not adherent to each other. Why there is a space? Because it represents data which is categorical data. It's a qualitative data. So I cannot adhere all bars together because each bar represents one group, one identity. Is it clear?
Yes.
No, it's not clear. Why specifically to put spaces?
Because if you don't put spaces like with what we will see later on, like the histogram, it means that you could have a value in between these spaces. So, for example, here we have the pneumonia severity index class, the class 1, class 2, class 3, class 4, and the class 5. Is it possible to have any person who could be a class between 1 and 2?
No.
So, okay, how could you put them stuck together while you cannot have a person who could be in between 1 and 2? As long as you put them adherent to each other, means that you have one of your sample who represents this 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 adherence. Is it possible?
Yeah. I got it. Yeah.
Okay.
Okay. Yeah.
Okay. Now, for the continuous data, let's speak now. We spoke about the qualitative data, and now we will shift to the quantitative data. As we say that the quantitative data is either continuous or discrete, right?
Yes.
The discrete data, when we present it in a graphical way, usually we deal with it as if it's qualitative, because the discrete data.
Excuse me, Dr. Sarah.
Sorry?
Yeah, I can see the new slide. It's still on the nominal and ordinal data distribution.
Which one? I'm still here.
On the bar chart, yeah.
Okay.
Dr. Sausan?
Yeah, okay.
So now we will shift to the quantitative data. And as we say that in the quantitative data, we have continuous data and discrete data. What about the graphical presentation of the discrete data? In the graphical presentation of the discrete data, because we don't, what's the main criteria of the discrete data?
No fractions.
We don't have fractions. So as long as we don't have fractions, we cannot put the bars stuck to each other, right?
Yes. Yeah.
Because we don't have the capability of putting the bars stuck to each other, we will deal with the discrete data in its graphical presentation like the qualitative data. So to sum up, we will present the discrete data with bar charts.
Okay.
Okay. Why?
Okay.
Because we don't have fractions. Okay.
Yeah, but it can include so many bars, right?
Yes. Yes.
Mm.
Okay. So the same example, the same 100 patients with pneumonia, but in this case, we want to assess the hemoglobin level of these 100 patients. Okay. Now we have the different levels of hemoglobin among these 100 patients. What's the type of our variable here? What's the type of the variable, the hemoglobin level?
Continuous.
Quantitative continuous.
Quantitative continuous. When our data is quantitative continuous, we present it with what's called the histogram. Histogram, the main criteria of the histogram is all bars are stuck to each other, because we could have fractions. So we could have someone whose hemoglobin level is 6.1, up to 7.1. So we could have a range of the values for all the x-axis, from 6 up to 14. We could have decimal for all these readings, okay? The main criteria of the histogram is all bars are adherent to each other, because we could have fractions. For the y-axis in this situation, for the y-axis in this situation, it's usually preferable to put the frequency, the number, not the percentage. Okay?
Yeah.
Okay. Sometimes we draw above this histogram like this dome-shaped line. Could you see it? On the other one. And in this case, we will call the graph frequency polygon, because we have these bars, and above these bars, we have this dome-shaped curve. This mixture is called the frequency polygon. And what's the importance of this? This is very important when we want to determine what's called the distribution of our data. Whether our data is normally distributed or not normally distributed. And why is this important? Because based on the distribution of our data, we will choose which type of statistical analysis we will do it. Okay?
Yeah.
Yes.
The most useless type of the chart is what's called pie chart. And all of you know what's the pie chart. It's like the pie, and it's divided into slices. And for each slice, it represents the different percentage of the different categories. Why this pie chart is useless and it's not preferable when, for example, when you publish your manuscript to present the data in pie chart, why it's not important? Could someone answer?
It's visually more understandable.
So you like it or you don't like it?
I like it.
You like it? I don't like it.
Why I think it's better for presentations, like PowerPoint presentations, but
sorry?
I think it's maybe it's okay for PowerPoint presentation or media presentations, but for a paper, I think
it does not give us an idea about any relations.
It looks like the bar chart in the aim.
No, for example, in the pie chart, I could present the data in the form of the relation between the age, the sex, and the levels of certain disease. So I could have two variables and present the chart. Yeah. While in pie chart, it's impossible to present this relation. And usually when we do the graphical presentation, we would like to see to show relations between different variables. It's not just to simply describe it. We want to see that, for example, the percentage of males is higher among those who had diabetes compared to females, or vice versa. So bar chart could do this for us, while the pie chart is impossible to give us an idea about the relations between different variables. So the pie chart is usually not preferable in presenting our data. We could use it for learning for learning purposes, but when we publish papers, we don't usually use it. Mm-hmm. Okay.
Yeah.
So this is the graphical presentation. These are the main three types of the graphs that we use to graphically present our data. We will shift to what's called the tabular presentation of the data. What's the tabular presentation? The same protocol. We will start with the categorical data, the nominal and ordinal data. How could we present the nominal and ordinal data? Let's have this example. Now we have a total study population of 53 persons, and we have among them 29 who are smokers. What's the type of this variable? The smoking status. What's its type?
It's a yes or no.
Yes.
Qualitative nominal.
Qualitative nominal.
Exactly. So it's a qualitative nominal. How could we present this info in a statistical way? We used to see these tables. So when we have the data, which is nominal and ordinal, we present it by what's called the frequency and the percentage. What's the frequency and what's the percentage? Now we have the total study population, the total sample size is what here?
53.
Exactly. How many smokers do we have?
29.
So what's the frequency of smoking?
Around 50%.
The frequency of smoking is the 29. We have 29 out of 53 who are smokers. And this 29, they represent what percentage from the total sample? It represents almost 50%.
Yeah.
So when we usually write our statistical analysis part in our manuscripts or in our thesis, what should we say? We will say that if our data or if our variables are categorical variables, we will present our data in the form of a frequency and the percentage. So this is like the clashy words we use when we present our statistical analysis part of the manuscript. The qualitative data or the nominal and ordinal data will be presented by frequency and the percentage. And this is the only way we could present our qualitative data by it. We don't have other ways to do it.
Mm-hmm.
Okay?
Yeah.
It's the same here for like the pneumonia severity index class. We have 5 classes, and for each class from the 53 population, we have 50% of them in class 1, 25 in class 2, 10 in class 3, 10 in class 4, and 5 in class 5. Okay? Do you follow or something is not clear?
Yes.
So please, if something is not clear, just tell me, okay?
Okay.
Okay. Now we will shift to the other type of the variables, which is the quantitative variables. Okay? So let's have this example. We have here 21 patients with pneumonia, and this is the different blood glucose levels of these patients. So what's the variable here?
Blood glucose level.
Yes, and what's its type?
It's quantitative continuous.
Exactly. So our variable here is the blood glucose level, and its type is a quantitative continuous. How could I summarize this variable? Because of course we will not present our data in this way. We will not present all the measures of the different patients. We need to summarize this in one reading. How could we do it? I think most of us hear about what's called the mean of the data. What's the mean? How could we calculate the mean? The mean is the sum of these different observations. How many patients we have here?
21.
So how many observations do we have?
21.
Exactly. So we will sum all these observations together, and then we will divide it by the number of the observations, which is the 21. This is what we call the mean. So what's the mean of the blood glucose level of our study sample is 1 milligram liter. This is the mean blood glucose level of the 21 patients with pneumonia. And how did we calculate this mean? We summed up all the readings or all the observations from the total population and then divided it by the number of the population. Okay?
Yeah.
Okay. And this is called measure of central tendency. Why it's a measure of central tendency? Because I want to present all readings in one value. And this value should be able to give me an idea about the different readings. Okay?
Yes.
Okay. Now, how could we present this blood glucose level in a graphical way?
Histogram.
Exactly. And to do this histogram, we will convert this variable into like we will group this variable into different groups. For example, the group 1 will take all patients with the readings from 30 to 49, and the second group from 50 to 69, and etc. Okay, and then we will draw our histogram like this adherent columns, and each column represents a range of the readings of the blood glucose level. And in the middle of this high column, this will be the mean.
Yeah.
Okay? Okay, guys?
Yeah.
Okay. So this is the best scenario, that we have our data and we are able to calculate the mean, and the mean, as we said, that we will sum all the readings and divide it by the sample size. But life is not easy like this. We hear about the median. What's the median? Did you hear about it?
Yeah.
What is it?
We usually order the data
Yes.
either from the lower to the upper or from the upper to the lower, and
Exactly.
then we took the middle of this order. It should be the median.
Okay, perfect. So as Dr. Maha says, that to calculate the mean, the median, first we will put our data in order, either in an ascending way or a descending way, and the middle reading of this ordered observation will be the median. So in this example, it's the same example, it's the same readings like the previous one. We all these readings and we put it in order, and then we will take the middle value of this ordered observations, which is also here what?
100.
Exactly. So now we have the mean and the median is the 100, okay? We hear about something else which is called the mode, and all these three M's, the mean, median, and mode, represent what's called the measures of the central tendency. What's the mode? Does any one of you know what's the mode?
Yeah, it is the most frequent observation.
Exactly. So it's the most the value is the most frequent observation. And in our example here, what will be the mode?
100. Yeah.
Exactly. So now we have the mean, median, and mode are all of them are the same. It's 100.
Mm.
And then when we look at this data, we will feel or we will see that this data are more or less like it's homogeneous, and we don't have very high or very low values of the observations. So it ranges from 33 to 169 in a coherent way. So we have readings for 33, 55, 56, 68, and etc. Okay? What will happen if we have a value like this? Instead of the 169, the last observation will be 500. What will happen to these measures of the central tendency?
I think it's going to mess it up because it's going to be considered an outlier.
I'm sorry?
I think it's going to miss all the mean and median and mode because it's going to consider an outlier comparing to the other numbers.
Okay, so you will not calculate any one of these measures of central tendency, or what will you do?
I think only the mean will be affected, but the median and the mode, it's the same.
Exactly.
Yeah.
Because
Only the mean.
As we say that, how could we calculate the mean? In the equation of the mean, what we put in the equation of the mean? We put the readings from the different observations, right?
Yes.
So when this value is changed, the mean will be changed because this value will change the calculation of the mean. But what about the median mode? In its calculation, do we consider these extremities? No.
No.
It will be the same. Okay. So this is why we call that the mean is affected by the outliers, because if we have very small values or very large values, this will definitely affect the mean. The mean will be affected by the distribution of our data, while the median and mode will not be affected. Is it clear?
Yes, clear.
Yes.
So in this case, consider this 500 readings, the mean will be 116 instead of the 100. Okay?
Yeah.
Do you follow or you get bored?
No, we are following, yes.
Following.
Okay. Why all this stuff? Why I'm serious in telling you these harsh stories? Because this is one of the most important steps to be able to do the analysis later on. So let's see this different. This is like, let's consider it the frequency polygon we mentioned two or three slides before. So we say that it's like we have a histogram, and above it we have this dome curve. Okay. Yeah. This curve is very important because when we draw this curve, it will give us an idea about the distribution of our data, whether our data is normally distributed or it's shifted or deviated due to high values or low values. And why this is important? Could you tell me why this is important?
To choose the best test.
Yes, exactly. To choose the best way to summarize my data. When my data is normally distributed, it doesn't differ whether I will give you the mean, median, or mode, because the three values will be exactly the same. Okay. But let's look at the right or left and left sides of the slide. We will have data which is either positively skewed or negatively skewed. Why it's positively skewed? Positively skewed when I have very large value like this 500. What happened in the mean when we consider this 500 reading of the blood glucose level? The mean is shifted to a higher value than the median and mode, right? When we recalculated it, becomes 116 instead of 100. Okay, yeah. So the mean is affected by the outlier, by the deviation of the data. Mm-hmm. So the mean in this case is not the good test to present the data which is skewed. In this case, I need to present my data with the median, not the mean, because the mean is affected by the values, and it doesn't give me an idea about the true value of the central tendency. Why? Because it's shifted. The mean, median, and mode are measures of the central tendency. What does it mean, central tendency? The measure which is more or less represents the center of my data. In this skewed data, does the mean represent the center of my data?
No.
No, so it's not suitable as a measure of central tendency when the data is skewed. Right?
Yes.
Yeah.
Tamam? Tamam. Okay. So what's better is the median or the mode. But mode is not usually used. We use the median. So to put it as a golden rule, when the data is not normally distributed, we use the median as a measure of the central tendency. When the data is normally distributed, I use the mean as a measure of the central tendency. We have two ways to reach to the conclusion that the data is normally or not normally distributed. The best way and the easiest way is the visual inspection of the data. So all software programs are able to draw these curves, this frequency polygon, and just by looking at this frequency polygon, we could say, okay, this data is normally distributed or not normally distributed, okay? The other way is doing some statistical techniques, and two of the most common statistical tests, something which is called the Kolmogorov, Simonarov, and Chabarov-Wilk. And these statistical tests give you a significant value. Okay, did you see this? Okay, it's here. So when it's not significant, it means, do you know what's significant and what's not significant?
Less than 0.05.
Yes, when it's less, when the value of significance is less than 0.05, this is significant. When it's more or equal to 0.05, it's not significant. So what about this value, this 0.20? Is it significant or not?
No,
Not significant.
Not significant, which means that the data is normally distributed. When it's significant, it means that the data is not normally distributed.
So this is the significance refer to the difference between mean, median, and mode, right?
No, in this for the test, you mean for the test? No, it doesn't test the difference between mean, mode, and the median. it depends on hypothesis. So it's another story. But
the significance refers to what here?
Significance refers to that your data is significantly different in its distribution from the assumed normal distribution.
So it's not normally distributed.
Exactly. When it's significant, it's not normally distributed. Because this statistical programs, it depends, like they consider they do repeated readings of the data to create the best distribution of this data in its normal way, and then he compare they compare your data versus the expected data. Okay.
So
when your data is different from the expected data should be normally distributed. When your data is different from the expected data, it's significant, which means that your data is not normally distributed. So
okay,
when
so
significant,
just to make sure I understood well, so this means that there is no significant difference between this and normal distribution. So my data is normally distributed in this example,
yeah,
right?
in this example, okay. Exactly, it's perfect. So when it's not significant, the data is normally distributed, and vice versa. Just remember one and consider the other one. Okay.
Mm-hmm.
So why this is important? Let's look at this example. In this example, this is one. This is table, and of a paper, and it was published, I think, in the New England Journal of Medicine. So one of the very famous journals. And let's look at this variable. So this is the HIV patients, and here they calculated something called CD value. The CD value is, this variable is a quantitative variable. So this variable, because it's a quantitative, should be summarized by which test? By which measure?
By which one?
I'm sorry?
What's the question?
I mean that when your data is continuous data, how could we summarize it? Using what?
Histograms.
No, not the graphical. I mean the tabular presentation.
Mean mode, standard deviation.
Exactly. Mean mode and median. So we use the mean when the data is what, and we use the median when the data is what?
When the data is normally distributed, we use the mean.
Yes.
Here would we use the median.
Oh, exactly. What they use here? They used here the mean. Okay.
Yeah.
So in this example, they used the mean. Okay. This is the way we write the value of the mean in the tables. Okay. So they used here the mean, and they classified the values based on the HIV, whether the people are positive or negative. Okay. And they were unlucky because they presented the data in this graph, in this figure. Okay. And we tried by ourselves to draw the distribution of the data based on their figure. And what do you see here?
Have outliers, it's positively skewed.
Exactly. So the data is what?
Not normally distributed.
Exactly. And what did they use to summarize the data?
The mean. They should have used the median.
Exactly. And this paper was published in the New England Journal of Medicine. Okay.
Can I add something?
Yes.
Yes, I can say that the data is not normally distributed from the standard deviation, because the standard deviation is more than half the mean.
Yes, but we didn't speak up till now till the standard deviations. Okay. You are right. Okay. I'm gonna tell you when we speak about the standard deviation.
Dr. Samar, can I ask a question?
Yes, of course.
If they have used the median, they should mention like only one value, no plus or minus standard deviation.
Yeah, so we use the median. Okay. For all the data, we present two measurements: measure of the central tendency, and this is what we already spoke about it, and the other measure is measure of the the deviation or the variation. And this we'll speak about it immediately now. And we have different types of it: the standard deviation, the interquartile range. So let's jump to it immediately. We will speak about it. Okay. So when we use the median, we use with it something called interquartile range. And when we use the mean, we use with it the standard deviation. We will speak about it immediately now.
Okay.
May I ask about this figure on this graph? What's it called, and when do we use this?
Sorry, I didn't hear you.
What is this graph or figure? What is it called, and when do we use this?
This one? This one?
Yeah.
Yes.
Okay. This is called the error plot. In this error plot, it's a way to present all readings. So, for example, we have the sample of 500 patients, and this circles, there is one circle for each patient. This, when we use it if we want to show the outliers. Look here, we have.
It's like the box and whisker.
Exactly.
It's the same.
Yes, yeah. Exactly. Now we will speak measures of the variability. This is, now we understand measure of central tendency because we want to have just one reading represent the center of our data. So what about the distribution around this center? This is what called the measures of the variability. The simplest and the easiest and the most understandable one measure of the variability is the range, which is simply the difference between the largest reading and the smallest reading. Okay? So when we use the easiest measure of the variability, we describe the range. We represent the minimum value and the maximum value of our readings. Okay? So this is the same example of the blood glucose level among the pneumonia patients. And after we order it, what's the range? What's the range here? It's the difference between the largest value, which is 169, and the lowest value, which is the 33. Okay? And this is the range. And simply we subtract both values from each other and represent it. Okay? But this range is not commonly used. We used other measures of the variability, which is the standard deviations and the interquartile range. Let's speak about it. It's the same example. The mean.
Could you go 2 or 3 slides before? Yes, here. No, yep. The range one.
This?
Yes.
Yes.
Okay. So we have the largest, and then we have it like minus from the smallest one.
Yes.
Okay. And then we get the range. Okay.
Yes. So in this example, you have what's the range of this?
When we write in publications, do we write the range just like 56, for example, or we use minimum and maximum?
Yes, we use minimum and maximum. Sometimes we present the data by minimum and maximum, but the range means is that you subtract the two values from each other.
Okay.
Okay. Dr. Gulana, is it clear for you?
Yes, that's fine. Thank you.
Okay. So now what's the standard deviation? It's the same example that the blood glucose level, and we calculated the mean for these readings. And as we said before, that the mean is 100 milligram per liter. Okay. Now let's look at this. Do you follow? You follow with me?
Yes.
Yeah.
We have here a line in the center. And as we said that this line of the center represents what? Represents the mean, okay?
Yeah.
What was our mean? Our mean is 100 milligram per liter. So this line represents the value of 100 milligram per liter. Okay. Now, I want to have all the observations and see its distribution around this mean. Okay. So I may have some people who have their readings which are 100, so it's exactly like our mean, and I will put their readings on this central line. Okay. And I have other readings which may be below the 100 or above the 100. Guys, do you follow?
Yeah.
So now what I want to do, I want to know to what extent each reading of this is different from the mean. So this difference may be by 10 in the positive, or by 10 in the minus, or by 20, or by etc. Okay? I will take each reading from this. Let's take an example. For example, the reading of 80. Where should I put this 80?
Minus 20.
Exactly. Let's take another example. This 68. Yes, right. Perfect. This 68.
Here.
Where should I put it? Around here. Exactly. And etc. Okay? Okay. If I do this and I summed up all these differences together, I will have the sum of this equals 0. Why it's equals 0? Okay, let's go back. When we use the mean as a measure of our data?
When it is normally distributed.
Exactly. And what does it mean, normally distributed data?
The data on either side should be equal to each other.
Exactly. So when the data is normally distributed, means that the two halves of the data around the central reading is more or less equal. So I have half of my data on the positive direction from the central measurement, and the other half of my data on the negative direction of my central measurement. Is it clear? So
yes.
If the two halves are more or less equal, when I sum all these readings by the positive and negative values, it will give me at the end 0.
Yes.
Okay, it's a mathematical issue. So in this way, I was not able to represent the distribution or the deviation of the different readings around this central reading. How could I do it? To overcome this problem from a mathematical point of view, I will square each reading. Okay? So I will take the difference here. Let's take an example. What was our mean? What was the value of our mean? 100. Let's look at the first reading. What's this reading?
Plus 69.
So what's the difference of the 169 from the 100 equals what?
Plus 69.
Exactly. I will square this value. It will be the one in the last column. Let's look at the second value. What's the second value? 33. I will see the difference between the 33 and the 100, and it will be minus 67. Then I will square this value, and I will do this for all the readings. Okay? Okay, guys?
Yes.
Okay. And then I will sum up all these readings, all these values, to have this value. Okay? After having this value, I will divide it by the sample size, which is 21 in our example, minus 1. This is the equation. Usually it's said it's n minus 1. Okay? And then I will have this value this value called the variance. When I take now I want to answer the question of how much each value is away from the mean value. So to answer this question, I will take the square root of this reading, okay? And this will be called the standard deviation. I will give this reading plus or minus because it will give me an idea about the readings on the positive side of the central measurement and on the negative side of the central measurement. And this is why when we sum up our data by mean and the standard deviation, we put the value of the mean and then we put the signals plus or minus and then we add the value of the standard deviation. Is it clear?
Yes.
I want to hear the others. Did
Yes.
you sleep? Do you follow? Did you sleep? Did you give up or what?
No,
Okay.
for me, it's just I have to practice a lot about this because I come from law background and I'm not really familiar with variance and mean and these things. So just ignore me.
No, I'm not. I will not ignore you. But if okay, I know maybe it's very tough. But if something, I like you to understand the concept. You are not a statistician, so you are not obliged to be able to calculate this. But at least understand the concept. So
Yeah.
I want you to know that when my data is normally distributed, I will summarize my data with mean and the standard deviation. You are not. You are not. It's not your role to understand how do we calculate it. I'm just telling you just to understand the concept beyond it.
Yes, yes, I got it. Yes.
So Dr. Said says that he could understand from the standard deviation whether my data is normally distributed or not normally distributed. And he says that if the standard deviation is more than half of the mean, means that it's okay. It's something that we concluded by experience. We don't have a theoretical background about this. So it's just for practical use. Because when we critically read some papers and we don't have the full data to be able to know whether the data is normally distributed or not normally distributed, we could pick it from the relation between the standard deviation and the mean. So to put it as a rule of thumb, when the standard deviation is more than 1/4 of the mean, the data is usually not normally distributed. Okay? Okay.
More than 1/4?
Yes.
But the standard deviation in the last example was 36, which is more than 1/4, right?
1/4
of the mean. Yeah, it's around 1/3.
1/3. It's almost 1/3. It's almost 1/3. Yeah.
But this was normally distributed data, right?
Okay. I got your point. Okay. Well, as I told you, it's from a practical point of view. So for conservative issues, when we read, because usually we use this technique when we read from the manuscripts. Okay. Doctora, so we are suspicious about the distribution of the data. In this situation, the data is normally distributed, but because the value of the mean is 100, but sometimes 1/4 of the value, which is 1/4 from the mean, could be not normally distributed. So like we call it the 1/2 is the flexible rule, and the 1/4 is the conservative rule.
So if it is more than 1/2,
it doesn't have any scientific background. Okay.
Yeah, I know.
So just by experience, some biostatisticians say that let's take it as a rule of thumb. If you see that the standard deviation is more than 1/4 of the mean, consider the data not normally distributed, just by their experience.
Okay.
So now we speak about the standard deviation and its relation to the mean. We have other measure of the central tendency, which is called the median, right? And we say that the median is used when the data is not normally distributed, right? So what's the measure of the variation in this scenario? The measure of the variation in this scenario is something called interquartile range, okay? So what's the interquartile range? The interquartile range, let's take this an example. So now we have what's called the PCR readings of different patients, okay? And this data is not normally distributed, as you see from this figure. So what will be our measure of central tendency?
Median.
Median.
And to calculate the median, as we know that we will have to order our data in an ascending or descending way, and the reading in the middle of these observations will be the median. So this median, above the median will be half of the data, and below the median will be the other half of the data, okay? So now we have 50% of the observations above the value of the median and 50% of the observations below the value of the median, right?
Yes.
Do you agree?
Yeah.
Okay, now what are the quartiles? Now we have two halves. We will divide each half into two other halves, okay? Okay? So instead of have two halves, we will have four quarters.
Mm-hmm.
So,
Yeah.
I'm sorry? So for the first half of the data, I will split it into another half. So I will have like 1/4 of the data above this reading and the other 1/4 of the data below this reading, right?
Yes.
Okay. And I will do the same for the second half of the data. Now I will have 1/4 of the data above this reading and 1/4 of the data below this reading, right?
Yes.
Right? So the reading of the first percentile, the first quartile, and the reading of this quartile is the interquartile ranges. What does it mean in wording? In wording that the first quartile, the reading of the first quartile means that I have 1/4 of the observations above this reading, okay? And the third quartile means that I have 1/4 of the data below this reading. As if I divided my data into 4 quarters and I take the value of the first quarter and the third quarter, because the value the value of the second quarter is the median.
Yes.
Is it clear? Something is not clear for you?
Oh, it's clear.
It's clear? Dr. Sarah, Dr. Safsan, all others?
Yeah, it's clear.
Yes,
Yeah.
clear.
Okay. This is the interquartile range. So now we finished today how to describe our data. We say that we describe our data in a graphical way or in a tabular way. And the graphical way, we have three main types of the graphs. The bar chart, we use it for the categorical variables and the discrete variables. And the histogram, we use it for the continuous variables. And the pie chart, we use it for all types of the variables, but it's not preferable. Then we speak about the tabular presentation, and we say that the tabular presentation of the data depends mainly on the distribution of the data. When the data is normally distributed, I present it by mean and the standard deviation. When the data is not normally distributed, I present it by median and interquartile. And this is the conclusion of all what we speak about the last 1.5 hours. Now we will come to the inferential statistics. What's the inferential statistics? We are doing this all stuff to either prove or disprove or to answer our research question. So let's start by asking a research question. Could you give me examples from your researches of your research question? What was your research question during your master or MD or whatever? I think all of you did a master, at least master.
Yeah.
So what was your idea in the master, Dr. Sarah?
Was decreased in sickle cell disease.
No, I didn't hear you. Could you repeat again?
Decreased bone density.
Okay.
In sickle cell disease patients.
Decreased bone density in sickle cell anemia patients?
Yeah.
Okay. So the research question for Dr. Sarah is she wants to assess the bone density among sickle cell anemia patients, right?
Yes.
And she assumed that the bone density is decreased among the sickle cell anemia patients. And she wants to reach to this conclusion. Am I speaking right, Dr. Sarah?
Yes.
Is it right in this way?
Yes, yes.
So what was the research question for Dr. Sarah? Someone else could interact, please.
If the sickle cell anemia causes decreased bone density in children or not.
Okay, so this is the research question of Dr. Sarah. She wants to know, she wants to assess the relation between sickle cell anemia and the bone density. And she assumed that the sickle cell anemia is associated with decreased bone density. Do you follow?
Yes.
Yeah.
Dr. Sausan, Dr. Syed, do you agree? Yeah. Okay. Yeah. So here we start to put this phrase in a statistical term, in an inferential statistical term. What we use to sum up what we speak about related to Dr. Sarah, it's called the hypothesis.
Yeah.
Dr. Sarah started her master by putting an idea, and we should formulate this idea in a research question, and the research question should be formulated in a hypothesis, and the statistics is an aid to help me to either accept or not accept or to prove or disprove this hypothesis. Okay?
Yeah.
This is not important. So let's imagine I want to predict the mean hemoglobin in whole diabetic patients from the study sample. So now we have here the total population, the total diabetic patients, okay, in my city. This is, I want to know the true mean of the hemoglobin from whole this population. As we said in the beginning that it's impossible to do the study on the whole population, so I should take a sample from this population. I will do the analysis from a sample. To what extent the mean I will calculate from the sample will represent the mean of the true population? To what extent my statistic that I will calculate from the sample will be equally similar to the parameter? Because as we say in the beginning that what we calculate from the whole population is called what? A parameter. Right?
Yeah.
So now I did my study and I calculated the mean of hemoglobin and it was 10. Someone else take another sample and he calculated the mean and it was 9, and someone else did it and it was 12, and someone else and it was something else. We want to put this together. So we are several researchers and we want to put all this together. How could we say this? Now we have the different means and the different and the standard deviation. Okay. If we consider, so I calculate the mean of the hemoglobin among the diabetic patients, and it was 10. And when I calculated the standard deviation, it was 1. Okay. So what does 1 present? It presented that someone could have the value plus or minus this. This is a little bit shifted. These readings are a little bit shifted. But let's look at the numbers. So what does it mean? That plus or minus 1, that the range of the data could reach from 9 to 11, right?
Yes.
If I have my standard deviation equals 1, it means that the range of data could be from 9 to 11, right?
Yes.
If I have my standard deviation equals 2, what does it mean? It means that the range of the data could be from 8 to 12, right?
Yes.
And if 3 from 7 to 13, and 4 from 6 to 14, and etc. What does it refer to? It refers to, if I use my data to present it in the form of mean plus or minus 1 standard deviation, I could give an idea about the distribution of the data among 68% of the total population. So my study sample, the readings from my study sample were represent the readings of 68% of the total population. While if I use 2 standard deviation, it will represent the 95% of the total population. And did you hear about this confidence level?
Yes.
So what does it mean, the confidence level, 95? We usually use this 95.
We are pretty sure that 95% of the population
Let's sum up. I'm doing my research on a study population, but I want to know the real readings of the total population. This is what we agreed on it at the beginning of the lecture, right? So how could my data present the real population? How could it? It could represent the real population by doing some statistical techniques. When I calculated the mean plus or minus 2 standard deviation, it means that the range of these readings could represent 95% of the readings in the total population, as simple as it is. And when I expand the standard deviation, it means that I will include much more of the total population, because this curve represents the total population. It does not represent my study sample. Okay, so I want my values to be broad as much as it can represent the total population. When I increase the values of the standard deviation, I will include much more people with me, right? Which means that it will better represent the total population.
No, it's not clear.
Okay, I'm gonna tell it again. Inferential statistics means that I want my data to well represent the data from the total population. I'm doing my study on the study population. And what we did in this previous part of the lecture, these calculations of the mean and the standard deviation, I did this on my study sample. Is it right? Now I want to refer these findings to the target population. Okay, because my aim is my data to be able to give me an idea about the target population. Is it right?
Yes.
Yeah.
Okay, how can I do it? I can do it by presenting as much as I can from the distribution of the data of the total population. And how can I do it? When I expand the values of the standard deviation, this curve represents the data of the total population, not my population. Okay? It's a theoretical curve to represent the total population.
Yeah.
Okay? So when I increase, instead of presenting my data by 1 standard deviation, I will present it by 2 standard deviation. So the mean plus or minus 2 standard deviation. What does it mean? When I presented the data like mean plus or minus 2 standard deviation, it means that I will consider 95% of the readings of the total population. And when I increase the value of the standard deviation, I will expand my data to increase the readings from the total population. It's like this curve, Dr. Sarah.
Yeah.
Did you got it? So instead of presenting the data between this range from, so the value from 11 to 9, it will be from 12 to 8, and from 13 to 7, from 14 to 6. So as long as I increase the value of the standard deviation, I will consider much more of the values of the total population. And this is the importance of the 95% confidence interval. What does it mean, the 95% confidence interval? It means that this data, my values, the mean and this standard deviation could be able to represent the real situation among the target population by 95%. Is it clear?
Yeah, okay.
So let's take an example of this hypothesis. Let's look at this example, because this steps, okay. At first, how could we test our hypothesis? We have 2 terms we use in the hypothesis, something called the null hypothesis and something called the alternative hypothesis. What's the difference between both of them?
They're opposite to each other.
Yeah, of course, they are opposite to each other. But the
null hypothesis, can I say?
Yes.
The null hypothesis is the one that that I suggest for my experiment, and alternative is if I got the result in a different way. Like if I suggest that she's gonna have the patient with sickle cells cancer, I think. If it's gonna have, excuse me.
Sickle cell anemia.
Yeah, anemia. So this is the basic thing. It's gonna increase or decrease. If I said in the null hypothesis is gonna be increased, so the alternative hypothesis is gonna be decreased, or vice versa. But the basic one is the null hypothesis.
Yeah, it's the basic one is the null hypothesis, but null means nothing. So the null hypothesis is it's like the hypothesis of the beginning of everything. What does it mean, null? In the example of this sickle cell anemia, it means that there is no difference. There is no difference in the bone density between the patients with sickle cell anemia versus the patients without sickle cell anemia. Null means that no difference. Null as a term means no difference, while alternative means that there is a difference. So usually we do our research to prove the alternative hypothesis, because this is what we want to reach to when we do our research. Dr. Sarah wants to conclude that there is difference in the bone density among patients with sickle cell anemia. The bone density is low among sickle cell anemia, while the null hypothesis should be that there is no difference. Null means nothing or no. The null hypothesis is the hypothesis that we should start our research by putting it, while the alternative is the hypothesis that we want to reach to it. As simple as it is. Okay? Yeah. So we start our research by
Samar?
Yes.
What's your timing on your presentation?
Still we could 15 minutes. 15 minutes on.
Okay. All right.
Okay. So the null hypothesis is that usually we start our research by putting it that there is no difference between what we measure among the different groups, while the alternative hypothesis is what I want to reach to. I want to say at the end that the bone density is lower among patients with sickle cell anemia, while the null hypothesis is there is no difference in the bone density between patients with and without sickle cell anemia. Is it clear?
Yeah.
Okay.
Yeah.
So let's read this example together, and it will be clearer. So this is a randomized controlled trial of this cranberry juice and the lactobacillus GG drink for the prevention of the urinary tract infection in women. This is a study, and this researcher wants to prove that the cranberry juice is effective in reducing the urinary tract infection among women compared to the lactobacillus, this type of the drink. Okay, so he took 150 women and he put them in groups. The first group, he gave them the cranberry juice. The second group, he gave them the lactobacillus drink. And the third group, he gave them, he didn't give them anything. In this case, in this scenario, what would be my null hypothesis?
That there is no difference between the three groups.
Exactly. Regarding what?
The prevention.
Exactly. There is no difference in the frequency of the urinary tract infection between the three groups. Do you agree?
Yes.
Yeah.
Okay. But what he wants to prove? This is the null hypothesis. What will be the alternative hypothesis?
That cranberry juice prevent or those who receive cranberry juice had less frequency of UTI.
As simple as it is, that there is a difference in the rate of the urinary tract infection between women who received the cranberry juice versus the other two groups of the women.
Yes.
You agree? You agree? Okay.
Yes.
How could we reach to the conclusion? So this is what we say, that what's the alternative hypothesis? What is the type of this variable? The rate of urinary tract infection, what's its type?
Numerical, discrete, quantitative, discrete.
Quantitative?
If we are going to calculate the frequency.
Yes. Whether they have or they don't have urinary tract.
Yes or no?
Yes.
Yes or no? Or how many times?
How many attacks?
No, no. Yes or no? Do you
yes
have?
Or no? Qualitative, nominal.
Yeah.
Nominal.
The variable here is a qualitative variable. How could we summarize the qualitative variables?
Frequency and percentage.
Exactly. So he already did this, and he calculated the frequency and the percentage of the women who developed the urinary tract infection after a certain period, and he reported that 16% of women in the cranberry juice, 38% in the lactobacillus group, and 36% in the control group had urinary tract infection. So now we have a difference between the rate of urinary tract infection among these groups, right? Right?
Yes.
Yeah.
Yes.
Then we need to test whether this difference is significant or not. Something called the chi-square, we will mention it in 1 minute. And he found that this test is significant, which means that what?
That there is a difference between cranberry juice and the other two groups.
Exactly. And now we could say that, will we accept the null hypothesis or we will reject it?
We will reject the null hypothesis.
Exactly, because the null hypothesis said that there is no difference, while when I did my study, I found that there is a significant difference, which means that the cranberry juice was able to reduce the urinary tract infection, and then I will reject the null hypothesis. Is it okay?
Yes.
Okay. Dr. Said?
Yes, okay.
Now this is the last slide. The last slide. We have our data, as we say, and now we want to compare our data as we did in the previous example, to compare between groups. So we summarized our data, we present our data in graphs, and now we want to compare our data. We want to compare our data by gender. We want to compare our data by education. We want to compare our data by social class. How can we do it? If our data is the qualitative data, and usually the qualitative data is the friendly data, we use the chi-square, and this is, okay? Now the problem comes with the quantitative data. We will classify the data based on its distribution, because usually we have problem with the distribution. Let's start with the normally distributed data. Do you follow with me?
Yes.
Yes.
Okay. We have the normally distributed data, and we will compare this data between groups. What does it mean? Let's take an example. If I want to compare the systolic blood pressure level between males and females, okay? This is my research question. What's the type of the systolic blood pressure variable?
Quantitative.
Continuous.
Continuous.
Okay. There
Okay.
is no fraction in systolic blood pressure, right?
No, there is a fraction. You could say 150, 100.50. You could read it by fractions.
Really?
Yes, by the digital sphygmomanometer, you could read it by fractions.
Okay, no problem.
Okay, so I have the systolic blood pressure, and this is quantitative continuous variable, and I want to compare it between males and females. This is my research point, okay? And this systolic blood pressure is normally distributed. What's the way of summarizing the systolic blood pressure? By what measure?
Mean and standard deviation.
Exactly, by the mean and the standard deviation. So now I wanted to compare the mean of the systolic blood pressure between males versus females. I want to reach to conclusion whether the mean of systolic blood pressure is higher males versus females or not. How can I do it? I can do it by calculating what's called the t-test. Okay?
Yeah.
So how can I use the t-test? The t-test is used to compare the mean of a variable between two different groups. What's the variable here is the systolic blood pressure. What are the groups here? The males versus the females. So I compared the mean of the systolic blood pressure between males and females. And my variable here is normally distributed. Okay?
Okay.
Yeah.
The first scenario. The second scenario. What's called before and after. What does it mean? I take a group of females, okay? And then I measured their systolic blood pressure today, and after 5 days, I re-measured their systolic blood pressure, okay? I exposed them to bad news, and then I measured their systolic blood pressure, and I want to test whether this bad news affected their blood pressure or not. So they are the same group, and I measured their blood pressure twice, one now and one after 5 days. Do you follow?
Yes.
Okay. So this is called before and after. When I have the same group and I compare the variable of the same group by 2 points of time, before and after, I did it by what's called paired t-test. Okay?
Okay.
Yeah.
Clear? Okay. Now, the third example. If I have more than 2 groups, what does it mean? It's the same systolic blood pressure. And I want to compare the mean of the systolic blood pressure between people who are living in 3 different districts or in 3 different cities. or in 3 different schools. So it's not males and females. There are more than 2 groups, more than 2 independent groups. I have students in school 1, students in school 2, students in school 3. And I want to compare the systolic blood pressure between the students in the 3 schools. How could I compare this? I could do it by what's called ANOVA test. This is like a roadmap for you. You don't have to memorize it, but just put it in front of you. When you do your analysis, you could pick which type of the variables and which type of the groups, and then you could choose which test to use. Okay? Okay, guys?
Okay.
Yes.
Okay. Now the same scenario for repeated measures. So it's also before and after. So it's before and after for the 3 schools. So I have the students of the 3 schools, and I measured their systolic blood pressure today and the next Thursday. So now I have 3 schools and 2 readings for each school. So it's like before and after for more than 2 groups. How could I compare their mean? By what's called repeated ANOVA. So it's like the ANOVA, but it's another technique called the repeated ANOVA because it's considered the before and after readings. Okay?
Yeah.
Now this is for the normally distributed data. What about for the non-normally distributed data? As we said, how could we summarize the non-normally distributed data?
Summarize what?
How could we summarize the non-normally distributed data?
Median and interquartile range.
Exactly. So now the same scenario. If my systolic blood pressure is not normally distributed and I wanted to compare the median of the systolic blood pressure between the males and the females, what test should I use? So what's equivalent to
Mann-Whitney test?
Exactly. What's equivalent to the independent t-test called the Mann-Whitney test when my data is not normally distributed? The same scenario. So the same group of females, and I measured the systolic blood pressure today and then the next week, and the blood pressure is not normally distributed. What test should I use? It's and it's similar to the paired t-test, but for the non-normally distributed. Okay? Now, if I have the systolic blood pressure for the 3 schools and this systolic blood pressure is not normally distributed, what test should I use? It's the cross-Calvaris test. Then, if I have the repeated measure for the 3 schools, I use something called Friedman test. This, you don't have to memorize it. Just put it in. You will never be able to memorize it, like a roadmap, okay? So this is the qualitative data. As we say, we compare it by the chi-square, and that's it. We don't have something. The last word is about the correlation. We have another technique in statistics called the correlation. The correlation is the statistical technique to assess the strength of the relation. So I'm not just telling you whether there is a relation or not. I'm telling you the strength of the relation and its direction. So if the age increases, the systolic blood pressure increases or not. If the age increases, the cholesterol level will increase or not. I could answer this research question by doing a correlation. And in correlation, I have 3 possibilities. Either to have a positive correlation, which means that when one variable is increasing, the other variable will increase. Or I could have a negative correlation, which means that one variable will increase, the other variable will decrease. Or I could have no correlation, which means that there is no relation between these 2 variables. I could do the correlation by 2 famous techniques, something called the Pearson correlation and something called the Spearman correlation. The Pearson correlation, if the 2 variables are quantitative variables and normally distributed, I will use the Pearson correlation. Put it as a rule. Then, if the 2 variables, one of it is not normally distributed or one of it is qualitative, I will use the Spearman correlation. And that's it. I'm totally done. And just my last question. with all these statistical techniques, we are not able to prove causation by the statistics, because causation needs another criteria that should be proved from the study design and etc. And statistics is one aspect of reaching to the causation. I finished. I know that we have other two exercises, but I think that we could do it through the forum if Professor Silverman allows me to do this.
Yeah, I'll attach it to the website. Okay, and would you want to do it in a discussion forum or as a assignment?
No, we can do it in a discussion forum. I know that they are totally exhausted now, so they will not be able to follow to do it now.
Oh yeah,
so,
no, not now. We need a break.
Yeah.
So let me take a look at it, and we'll decide. Yeah. Okay. All right. Good. Very good. So that was that was a good foundation for future presentations. Very